Today we will solve the problem 7.12 of Griffith third edition Introduction to Quantum Mechanics. The problem 7.12 is consider a quantum system with just three linearly independent states. The degeneracy is 3. Suppose the Hamiltonian in matrix form is H is equal to V naught V naught times this matrix 1 minus epsilon 0 0 0 1 epsilon 0 epsilon 2 where V naught is a constant, epsilon is some small number. This is perturbation. So first section A is write down the eigenvector and eigenvalue of unperturbed Hamiltonian, that is epsilon naught equal to 0. Now there are three states I labeled as chi1, chi2 and chi3. Chi1 is this first one. Here epsilon is 0, so naturally V naught into 1 is V naught. 1 0 0 V naught. Then what about second one? Second one is this. So chi2 is 0 1 0, of course with eigenvalue V naught. Similarly chi3 is this one, that is 0 0 1 with eigenvalue 2 times this V naught. So we have answered the section A. Now we will move to section B. Section P is solve the exact eigenvalues of H, that is Hamiltonian matrix with perturbation, of course. Expand each of them as a series in epsilon up to second order. We have to find the value up to second order. Now the given matrix is V naught 1 minus epsilon 0 0 0 1 epsilon 0 epsilon 2. Now you multiply this by V naught. V naught 1 minus epsilon, and here you have V naught, here epsilon V naught, and epsilon V naught 2 times V naught. Now in order to find the eigenvalue, you find the determinant of this by subtracting the lambda. So in the diagonal matrix, as usual procedure, diagonalize this matrix. Here you have minus lambda, here you have minus lambda, here 2v naught minus lambda, here v naught minus lambda, here v naught 1 minus epsilon minus lambda. Now you find the determinant. For determinant, you take this value, that is v naught 1 minus epsilon minus lambda, first one, and multiply by this v naught minus lambda, 2 v naught minus lambda, of course this and this, minus epsilon squared v naught squared. Here in order to have a value determinant 0, this first term will be either this one will be 0 or this one will be 0. So there are two possibilities. If first term is 0, it will happen only when lambda is equal to V naught 1 minus epsilon. This is, we are calling it as eigenvalue 1. Lambda 1 is equal to V naught 1 minus epsilon. This is the first order correction. Then what about other eigenvalues? Here you can multiply this. If you multiply V naught minus 2 V naught lambda, then you will get 2 V naught square minus 3 lambda V naught. That is, here you will have V naught minus lambda, minus V naught lambda. Here minus lambda 2 V naught. So naturally you will get 3 lambda V naught. If you multiply this and this, you will get 2 V naught square. Of course, then this minus lambda is plus lambda square minus this term epsilon naught epsilon squared v naught square, which must be equal to 0. This is the quadratic form. So with respect to lambda, I can rearrange and write this lambda squared minus 3 v naught lambda plus 2 minus epsilon squared v naught squared. Here this is quadratic with respect to lambda. So naturally lambda is minus p. Here you can see p is minus 3 v naught. So this will become 3 v naught plus or minus square root of p squared. This is square it 9 v naught squared. Then 4 AC. A is 1 here. Minus 4 C is this one entire thing. 2 minus epsilon naught squared v naught squared. This is C. Now you take v naught squared outside. Since it is under square root, it will simply become v naught. Then remaining parameter is 9 minus 4 into 2 is 8. That means 9 minus 1 is 9 minus 8 is equal to 1. Then minus 4 times this one, epsilon naught. So this will become square root of 1 plus 4 epsilon square divided by 2. So now we can find the other two eigenvalue. One is with plus and other one is with minus. We got this value for lambda. So you take v naught divided by 2. Then inside you can take this 3 plus or minus square root of 1 plus 4 epsilon 1 plus 4 epsilon squared. But if you approximate this 1 plus 4 epsilon squared, that is in the square root, this can be approximately written as 1 plus 2 epsilon square. So by using the expansion series, you can write this as 1 plus 2 epsilon square. Now you take minus negative sign first. I'll tell you the reason also. So 3 minus 1 is equal to 2. 2 because we are taking minus 2 epsilon square. This will become minus 2 epsilon square. You take 2 outside, so that 2 and this 2 will cancel out. This will simply become v naught 1 minus epsilon square. So this is the second order correction. Then we have seen chi2 is v naught. Eigenvalue of chi2 is v naught. So eigenvalue lambda 2 is v naught. With correction, it is v naught minus epsilon squared v naught. Then what about lambda 3? You take a positive sign. So 3 plus 1, you will get 4 and plus 2 epsilon squared. You take 2 outside. This will become v naught multiplied by 2 plus epsilon squared. You remember that the eigenvalue of third element chi3 is eigenvalue of chi3 is 2 v naught. This is of course correction. That's why I have taken minus first then plus next. So this will be 2 naught is the energy and the correction is epsilon squared multiplied by this v naught. Now we will move on to section C. In section C, use first and second order non-degenerate perturbation theory to find the approximate eigenvalue for the state grows out of the non-degenerate eigenvectors of H0. Compare the exact result obtained from P. Just now we got this. So H is equal to, we have seen that matrix form. It is 1 minus epsilon 0 0. Of course you have v naught multiplication factor 0 1 minus epsilon 0 epsilon 2. So naturally, what is the perturbed Hamiltonian matrix? So perturbed Hamiltonian matrix, you remove this one. One is unperturbed here, one is unperturbed, two also unperturbed. So this will become. I have taken epsilon naught out. Yeah, sorry, epsilon outside. So this is epsilon v naught. So already v naught is here. This epsilon is minus epsilon. So this will become minus 1. This is unperturbed state, so 0, energy correction is 0. Here also unperturbed state. This 2 also will become 0. This epsilon 1 and this epsilon 1. So the perturbed Hamiltonian can be written as epsilon v naught minus 1 0 0 0 0 1 0 1 0. Now we will find the answer path is 1. And now we will find the first order energy correction path, the energy state 3. Of course, here I like to highlight you can take for energy state 2 or energy state 1. Of course, since we are going to calculate the energy correction for all the energy levels, so you need not worry. I have taken third state first. So the first order energy correction is, by definition we have seen that it is nothing but the expectation value of perturbed Hamiltonian in unperturbed energy state, that is chi3 0 h prime chi3 0. So the matrix h prime is epsilon v naught minus 1 0 0 0 0 1 and 0 1 0. And what about this? This bra vector is column vector. We have taken third state, energy state. So naturally this will be 0 0 1. And bra vector is a get vector is a column vector with this 0 0 1. So now you multiply these two matrices, then minus 1 0 0. If you multiply with this column you will get 0. Now if you multiply this and this, uh, you will get 1 here in this row matrix. And similarly this multiplied by this you will get to 0 again. Now you multiply this and this, naturally this will be 0. What about second order energy correction? It is not simple. We have seen theoretical lecture on degenerate energy level corrections, that is summation over m is not equal to n. Here n is 3, so that means we have 3 state, m is equal to 1 and 2. So this can be written as chi m h prime chi 3 modulus square E30 minus EM0. So this is the definition. You can refer my theoretical lecture on degenerate energy state. That is perturbation, degenerate perturbation. I have given in that lecture clearly. So now you find the take m equal to 1. So you will get chi 1 h prime chi 3. So which is epsilon naught v naught. Chi 1 is 1 0 0. It's a row matrix, and chi 3 is a column matrix 0 0 1. Epsilon v naught, this matrix is this perturbation matrix. So as usual you multiply this and this. So first row this column naturally is 0. Second row this column naturally it will be 1, and third row this column is naturally is equal to 0. Then you multiply this with 1 0 0. Naturally you will get 1. Second, that means there is no second order correction. So first order correction also 0 we have seen, and second order correction also 0. We will go for next energy state. So the second order energy correction of eigenstate 3 is equal to, with respect to chi 2. Just now we have seen with respect to chi 1 is 0. With respect to chi 2, you use the chi 2 matrix 0 1 0. It's a row matrix, and chi 3 as usual 0 0 1 is a column matrix, and this is the Hamiltonian matrix, perturbed Hamiltonian matrix. So you multiply this and this. First row this column 0, second row this column 1, third row this column is 0. Then here you multiply this and this, you will get 1, that is epsilon v naught. So the second order energy correction with respect to the energy state 2 is epsilon v naught. With respect to energy state 1 is 0, just now we have seen. So you add both. So in the first case we have seen this is 0. In the second case we have seen this is epsilon v naught. That means epsilon squared. You have to take modulus squared. Epsilon squared v naught squared. What about E3 0? That is unperturbed energy state E3. In section A we have seen the eigenvalues 2 v naught. For energy state 2, the eigenstate is v naught. So 2 v naught minus v naught, which will become just v naught. This v naught will get cancelled. This v naught will get cancelled with this v naught square. So this will become epsilon squared v naught. So the energy correction in energy level 3 is E3 0, E3 1 and E3 2. E3 0 unperturbed energy state is V naught, and first order perturbed is just now we have seen it is equal to 0. Then third energy state, third order correction is epsilon squared v squared. So we got epsilon squared v squared. This is equal to the perturbed energy. This is unperturbed energy, so you don't worry. Now we have to see only the perturbed energy, so you can remove this. This is unperturbed. So perturbed energy state is epsilon squared v naught. Now we will move on to next energy states. Section D. Use degenerate perturbation theory to find first order correction to the two initial degenerate eigenvalues. Compare the exact result. So from perturbation theory we have seen W sub AA is equal to chi1 H prime chi1. So the H prime is epsilon v naught and this matrix, and chi1 bra chi1 is row matrix 1 0 0, and get chi1 is column matrix 1 0 0. So as usual you multiply this matrix and this one. What you will get? This is the perturbed Hamiltonian matrix multiplied by this column matrix. First one you will get minus 1. Second row this column 0. Third row this column 0. What about this column matrix 1 0 0? So epsilon v naught 1 0 0. If you multiply this and this, you will get minus epsilon v naught. Then similarly, what is WPP? This is related to chi2 chi prime H prime get chi2. So this is WPP. We have seen in detail in the degenerate perturbation theory. So chi2 bra chi2 is column row matrix 0 0 1 0, and chi2 get chi2 is column matrix 0 1 0, and this is the H prime perturbed Hamiltonian matrix epsilon v naught minus 1 0 0 0 0 1 0 1 0. If you multiply this and this, first row this column is 0, second row this column is 0, and third row this column is 1. Here if you multiply this and this, naturally this will be 0. That is WPP is equal to 0. Next WAP which is equal to the bra chi1 H prime get chi2. by definition it is like. So you take as usual the Hamiltonian, perturbed Hamiltonian matrix, and bra chi1 is a row vector 1 0 0 and get chi2 0 1 0. Now you multiply first row this column 0, second row this column 0, then third row this column is 1. So if you multiply this and this will be going to be 0. Now from degenerate perturbation theory, the first order energy correction is E plus or minus 1 is equal to half WAA plus WPP plus or minus square root of WAA minus WPP whole square plus 4 modulus WAP square. Here this is very simple. We have seen WPP is equal to 0. From section C also we have seen WPP is equal to 0 and WAA is minus epsilon V naught, and WPP here also 0. Here WAP also just now we have seen this is 0. So we have got that 0 0, and WAA is minus epsilon V naught whole square. So if you take the square root, you will get plus or minus epsilon V naught. So now the energy correction is, if this is plus, you will get 0. If it is minus this, so minus epsilon V naught minus epsilon V naught, you will get minus 2 epsilon V naught. This 2 will get cancelled. You will get minus epsilon V naught. So energy level 1 is V naught, and this perturbed energy state minus epsilon V naught. The energy level 2 is 0, that is V naught minus 0 is V naught. So we have solved. This is exactly matching with the our section P and C. So thank you very much for watching my video and supporting me continuously. Thank you very much.